In this video, we're going to go ahead and discuss the basic Swashplate setup and also some of the new features that you want to make sure that you get the details right on in setup. So first thing we're going to do is go to Swash Set Basic. And in this helicopter, I've left some of the numbers in it so we don't have to go through all that. But the first parameter is going to be setup style. Setup style, the options are 3D and F3c. 3D mode has a lot of combinations and all the new features basically turned on automatically. So you're going to get a new parameter list and you're going to get a bunch of different parameters that actually work together to change mostly just the feel of the helicopter. F3c mode is a little bit different. It's actually version 1.4 naming structure and things like that, but with condition switching. So if you had a helicopter on 1.4 and you really liked it, you could leave it there and then it would give you the added edition of the conditions 1 and 2 to have two separate flight styles. For me personally, I would recommend just setting it up in 3D. We've had a lot of guys test it for F3c, for scale, for 3D, in 3D mode, and we found that the combinations work really well. It also gives you some of the new parameters that we're going to talk about here turned on automatically. So I have mine set to 3D. We're going to go to the next parameter, and this is going to be the operation mode. So the options are gyro plus throttle or gyro plus governor. If you're using the internal governor for your nitro or electric helicopter, you're going to select gyro plus governor. If you're using the internal governor on the speed control or straight throttle curves or something like that, you would choose gyro plus throttle. The next parameter is your servo frequency. This you're just going to have to look at your servo. If you're not using Futaba servos, you're going to have to look at the manual and see what operating frequency that they need to be driven at. Most of the Futaba, the digital servos, all of them are 285 hertz. The next is your Swash type. So this helicopter here is 120 degrees, so I have it set at 120. The CGY750 supports 4 servo, normal mode, 120, 140, so any helicopter will work. The next parameter is servo combination direction. I have mine set on 3, but basically rotate through here, and once you get the sticks working in the correct order, so elevator is elevator, aileron is aileron, and collective is collective, that combination is good. You can actually rotate through, and sometimes you might be able to get all the directions right, but if not a big deal. Because the next parameter here is Swash Direction. So you see if I hold full left, right now mine's on positive. If I hit negative, it will reverse it for you. So go through and set your right and left, set your elevator, and these numbers are just positive and negative, and your collective pitch. Next parameters are your Servo Neutrals, so just go through and make sure everything's neutral. One little trick that I've always done is on my normal mode I take all the negative pitch out of the normal mode, and so just the stick all the way down is neutral, and you can put your swash leveler on, get your blades all neutral. It is very important to make sure that 50% or 0%, depending on your throttle curve and your transmitter, is 0 degrees pitch. That is very important now with the new collective pitch pre-compensations, and we're going to actually set that later in the gyro. So my aileron, elevator, and pitch neutrals are all set. The next parameter is the Swash Rate. This actually sets the amount of base compensation for all the new pre-compensations, so it's pretty important to follow the cyclic pitch rates that we've recommended in the manual on page 11. For a 450 and below, about 6 degrees. For a 500, about 7 degrees. 600 to 550 size, about 8 degrees. 700 size, about 9 degrees, and an 800, about 10 degrees. These numbers are based off of actual aerodynamics and things like that that seem to work well with our gyro. So those are a good starting point. To kind of troubleshoot later on, if the helicopter is not pirouetting flat or if it's not rolling straight, changing this number up and down slightly will affect that. So that's something you can kind of tune a little bit on your own. A heavier rotor blade or a more stable rotor blade might take a little bit more pitch to pirouette flat. So this is a pretty important parameter. Next parameter is the pitch rate. This is purely just your collective pitch. So as you can see, it's just your high and your low. The biggest thing is, once again, like I mentioned before, make sure that your dual rates are 0 to 100 in your pitch curve. Swash ring, this parameter is also fairly important. This sets your amount of overhead cyclic. So after you set your swash rate, you might only have 9 degrees, say you're flying on a 700, but your mechanical limits allow for, say, 12 degrees. In the swash ring, this is where you can maximize that, and so as you can see, as I increase this, it just purely increases. You want to go ahead and increase it until the helicopter starts to bind. So by checking that, I would set it at mid stick, set as much as you can, and then go high stick, make sure it doesn't bind, and low stick, make sure it doesn't bind. Okay, your aileron and elevator gyro. This is simply just checking to make sure that your aileron directions are correct. Obviously, this is very important. This also presets all of your compensations. So by simply picking up the helicopter, you can rotate it. The swash plate should always actually try to level itself from where it was. So say you tilt the helicopter back, it's going to give forward elevator to try to keep the swash plate level relative to the horizon. Okay, the next parameters are all stick directions. So what you'll do is you'll move the stick to full. This is asking for full right, and I'll hit set. The next parameter, elevator back, set, and once again, make sure your dual rates are 100 and 100. The next parameter is also pretty important for the elevator compensation, so make sure you set this. The pitch low, so go to your absolute lowest limit and hit set. Go to 0 pitch. You can use the transmitter's servo monitor to make sure that you're exactly at 0, and once you're there, hit set. At this point in time, it would also be good just to put a pitch gauge on the helicopter and double check that you're at 0 degrees pitch. And the next parameter is pitch high. Same thing, full pitch, 100%, hit high. So that actually covers Swash Basic, and everything now is preset for you, and it's time to go ahead and move on to the Sbus menu now that we've got everything going in the right direction and nothing's binding. So we'll scroll to Sbus Basic. This is simply most of the parameters, since you're using Futaba radio, that will just carry over. If you are using the SBE01, you might have to change some of these the settings a little bit. So Sbus channel 1 is aileron, elevator channel 2, throttle channel 3, rudder channel 4, collective pitch channel 6. A new parameter with 3D mode activated is called rotor head gain. What this does is gang your aileron and elevator to one channel. So now in this case you have 3 channels, just whatever channel you assign it to in your function menu will be the correct channel. So in this case I have mine set to channel 9. And then your rudder gain I have set to channel 5. RPM will be for your governor. That's going to control your governor. RPM. Governor switch is the on and off if you're using a switch position instead of stick switch. The new parameter that you really want to make sure that you set is this condition selection. It says CND, and then I have mine set to DG1. You can also set to DG2, and what that does is whatever switch or control function or control condition that you set to, this is going to change with DG1. So as I've got mine set to SE for idle up, and as I go back and forth I'm changing from condition 1 to condition 2. Okay, that completes your Sbus setup, and basically your helicopter at this point in time, rotor head wise, is ready to go ahead and test fly. Okay, so now that we've got that base setup done, the helicopter is ready to fly cyclically, but I wanted to go ahead and touch on one of the other parameters or functions of the CGY750 that actually most of the gyros don't have. So by holding down the plus mode button for a period of time, there's a menu that says Swash Set Detail. What this does, it allows you to get CCPM helicopters completely pure of interaction, Swashplate interaction, and basically just unwanted behaviors. It could also be said to be linkage compensation. As servos deflect and swash plates deflect, angles and geometries change that you just can't avoid. So what Futaba's done is they've developed a mixing system that actually allows you to mix that out. So the first parameter is pitch to aileron. The way that you would check this is you would set your stick at middle and then slowly move the swash plate up and down with the collective stick. You can use a pitch gauge, or some swash levelers have this, and just make sure that the swash plate is staying flat as you move it up and down. If it's not, by using this number, say there's a value for low and high, A and B. So say at high we have a little bit of left aileron or right aileron. By using this number, you can see I'm actually dropping one side of the swash plate, and so the swash plate is now moving like this. This is what allows you to actually get everything completely flat. So the next parameter we'll go to is pitch to elevator. It's the exact same thing. At middle stick, your neutral values are setting these. As you go high and low, make sure that your swash plate is moving perfectly flat as you move it up and down. The next parameter is aileron to pitch. The way to check this is you set your stick at middle, and by cycling the aileron back and forth, you get letters A and B. What you're checking for here is to make sure that not only is the swash not moving up and down, but it's staying level with no elevator interaction. So one way to do this is to take a Sharpie and just mark a line on your swash plate and look at the control ball. The other way is to look at the back of the swash plate. In this case, this helicopter's got a swash driver in the back here, and make sure that as you cycle the ailerons, the ball is staying perfectly flat, and that this post back here is not rocking back and forth. Same thing, A and B. Simply lowering or raising one servo will fix that. Okay, elevator to pitch is the exact same thing. So whatever servo you have plugged into pitch on the gyro, that's the servo it's going to affect. So in this case, at mid stick, I'm going to cycle the elevator and check to make sure that the ball is not going up or down, and that also the swash plate, as it's tilting back, is not tilting back and forth like this. Okay. The next parameter is elevator to aileron, so this is going to adjust the aileron servo, whatever you have it plugged into. Same thing, making sure that the ball is staying flat as you're moving up and down as you're cycling it, and that your swash plate is staying level. By raising and lowering the number, you're going to raise or lower that number. It changes with servo direction set, so you're just going to have to push it one direction and see if it makes it worse or better. The next parameter is called Swash Cp. So this is for the ailerons. This is your high and low. So now that we've got it level and moving pure in the middle, you want to go to your high stick. That's going to give you a value, say A, B, or C, or D. And then at high stick, cycle the aileron. What this is going to do, if you notice, if I reduce this all the way down, this direct link servo helicopter, the swash plate is going to drop when I move it over. By increasing this value, what that will do is keep it completely pure, so as I move it down, the swash plate does not drop. So this is actually a 4 position value, so you'll need to do it at high, left and right, and low, left and right. Okay. If this is backwards, these values only go from 0 to 100. If this is backwards, there is a CPA direction. What this does is reverse that. So if I hold full aileron right now, you can see the ball didn't move. If I hit reverse, it's going to compensate in the other direction. So if it is compensating in the wrong direction to try to stay neutral and keep your ball level and your swash plate level, just go to the next parameter and reverse that. Plus or minus. Okay, the next parameter is the exact same thing, but for the elevator, high, up, down, low, up, down. And CPE direction, same as the aileron setting. Speed comp, what this does is on CCPM helicopters, specifically say a 120 degree, some servos are moving at a different distance than the others to create, say, the elevator action. So what speed comp does is it slows down the front servos to match what the back servo can deliver. So as I cycle the elevator here, you'll see it's staying perfectly flat. With this one happens to be at 0. Say you're getting some wave in the swash plate. By increasing this, you can see what it's done. It's put a delay in the servos to compensate for whatever that is. So default, I believe, is 50. And 0 obviously would be the other direction. So it would just be passing everything through, not slowing these down at all to match your back elevator servo. Swash rotation is effectively the phasing. So in most flybarless helicopters, the swash plate phasing is fixed. So just check to make sure that when you build your helicopter, the swash plate position that's controlling the ball is perpendicular to the rotor blades or the rotor head. If it is not, then you can either, if you don't want to mechanically change it, you can put some phasing in, and this goes by amount of degrees. So as you see here, when I move the stick, I'm not getting any elevator input whatsoever. It's just purely the two aileron and pitch servos. By adding this, by only adding elevator, it puts in an elevator correction. So say your helicopter isn't even rolling correctly, it's corkscrewing a little bit. You can actually adjust this swash rotation to get the helicopter to roll straight. Okay. And at that point, that's your swash detail menu. As I recommended, it does change the way the helicopter flies, and it's going to make it a lot more pure in the air and things like that. So it is worth it to sit down and do those things. That concludes actually the entire rotor head setup, and so make sure to go ahead and watch the next segments here on the tail rotor and some governor stuff.